Michigan State University. And the topic of this week's presentation is nutrient management in established plantings and how to correct nutrient problems once the crop has been established. So, Eric, I'll send it to you.
Okay. Happy New Year, everybody. It's a wonderful 46-degree sunny day in central Michigan, just a typical mid-January day for us. So what we'll be covering here today is approaches to correcting nutrient problems in existing plantings. And previous webinars have covered topics such as the soil characteristics and testing of soils, interpretation of the testing, and then pre-plant soil treatments, also plant tissue analysis and interpretation of analysis, as well as symptoms of nutritional problems. So that's great background for what we'll cover today, which is what to do if a nutrient need is known. So I'll cover macronutrients, primarily nitrogen is the primary concern, and then go through some of the micronutrients that can become problems in berries, and then also talk a little bit about fertigation, because I know a number of growers in different regions use fertigation. So let's first consider nitrogen management. So this is, of course, important because nearly all of these berry crops require nitrogen on an annual basis. So the big question is, what can you do to use nitrogen efficiently? And in that regard, there are questions about the fertilizer type, the rate, the timing, and the placement of those. So those are the 4 items I'd like to go through for under nitrogen management. First, regarding the nitrogen fertilizers, a lot of them to choose from here. I wanted to point out generally those with the highest nitrogen contents are the cheapest per pound of nitrogen. So those are generally the most preferred sources. And of course, these also vary in their reaction in the soil. So most of them, certainly all of them that supply nitrogen in the ammonium form or a combination of ammonium and nitrate, tend to have an acidifying reaction in the soil. And those that supply nitrogen only as nitrate have a basic reaction in the soil. And the measurement of that is called the lime equivalent. And that's on the far right here. And the lime equivalent is essentially the pounds of lime that would be equivalent in reaction to 1 pound of nitrogen supplied as a nitrogen fertilizer. So if you were applying a pound of nitrogen as calcium nitrate, that has a positive number, and it indicates that for every pound of nitrogen applied as that source, that would have equivalent reaction in the soil of 1.3 pounds of lime. So not a bunch of lime, but it certainly over time can affect pH of soils. And then those with negative numbers indicate that you would have to add lime to neutralize the acidity supplied by those sources. And we'll talk about ammonium sulfate as being a great nitrogen fertilizer for blueberries. Well, one of the reasons for that is it's so acidifying. For every pound of nitrogen you supply as ammonium sulfate, you'd have to supply 5 pounds of lime just to neutralize the acidity. So choosing these sources is indicated first cost per pound of nitrogen. Secondly, whether there's a need for additional nutrients. So the primary issue there is phosphorus. So that would be a reason to choose ammoniated phosphates, monoammonium or diammonium phosphate. Whether you want to change soil pH and which direction, and then also volatilization losses. So for blueberries, the materials choice are urea if the pH is below 5. So if it's below 5, you want to maintain it in that range. You'd use the less acidifying urea. You might also choose MAP or DAP if phosphorus is also low. And then we typically say if the pH is a little bit high and you'd like to reduce it somewhat, then ammonium sulfate would be the choice there. And MAP and DAP would again be good choices if you are in need of phosphorus. For brambles and strawberries, usually the cheapest forms are best, so urea or ammonium nitrate are good choices there. I know a number of growers use calcium nitrate, and there may be some reasons for that, particularly in the middle of the summer when there's some concern about volatilization losses from urea. So this volatilization aspect is something that we primarily are concerned about with urea. And when you apply urea prills to a soil surface, the first thing that happens to that prill is hydrolysis. So as it takes up water, that small organic molecule of urea hydrolyzes and it produces ammonium and bicarbonate. And an important aspect of this is that this has an immediate effect of increasing the pH around that prill or in the immediate vicinity. So if ammonium is present near the soil surface under high pH conditions, then it can be converted to ammonia gas and lost to the atmosphere. So part of the reason this is an issue with urea is because of this pH increase that you get immediately after applying urea. It's not to say that ammonium that's applied as, say, ammonium sulfate can't volatilize. It can also, but in most cases, pH of the soil is low enough to where volatilization losses aren't a real big deal. So what increases the potential for volatilization losses of ammonia gas? Well, first off, if the urea particle remains on the soil surface, so if you don't irrigate it in or you don't receive rain for several days, then that increases potential for losses. If the temperatures are very high, so if they're above 80 degrees, then that increases the potential for losing more of the nitrogen in urea. And then, as I mentioned, if the soil pH is high, this also increases potential for losses. So in the case of blueberries, where soil is pH is naturally low, there's less likelihood of losing nitrogen in the form of ammonia gas. But it is something to consider in the case of strawberries in particular, where we might be fertilizing in the middle of the summer where the temperatures are real hot. You'd want to make accommodations and for reducing that potential, and usually that means irrigating that fertilizer into the soil to protect it. Nitrogen rates. So applying the proper rate is important as far as optimizing the efficiency of nitrogen use by any crop. So if you apply more than the crop needs, you're going to have a lower use efficiency, and you may cause other problems as well. So rates vary from state to state and region to region, and certainly due to different soil types. And what I have here is just a general range for nitrogen rates starting with blueberries. So you can see that we start with 1 or 2 year old fields at 15 to 20 pounds of actual per acre, and then that's just ramped up over time. And then by the time you get to a mature field, you might be applying between 70 and 40 pounds of actual nitrogen to the acre. And the rates here depend primarily on the soil type. So the sandier the soil, lower the organic content of the soil, the higher rate you would probably need. Nitrogen rates for brambles. Here, again, starting somewhat lower rate, 20 to 40 pounds the first year, up to 30 to 60 pounds the second year, and then up to 50 to 100 pounds in the third year and older plantings. So again, the higher rates would be applied on sandier soils, and there's some indication that fall-bearing raspberries would require higher rates than, say, summer-bearing raspberries. And I think this makes a little bit of sense if you consider those poor plants are cut down to the ground each spring. They're generating a whole new stand of canes, as well as producing a crop of fruit all in one season. So growers, particularly on sandier ground, will find that rates even as high as 100 pounds may be optimizing yield for fall-bearing raspberries. Strawberries, again, these rates vary somewhat from region to region, but generally we think about 40 to 60 pounds of nitrogen to the acre during the planting year, and then 50 to 100 pounds per acre during the production years. So these rates, again, are going to be highest on the sandier soils. So a little bit about rates, but how about timing? I think timing is a critical factor as far as trying to optimize efficiency of nitrogen use. And in Michigan, we feel that a good system would be to apply fertilizer in a split application, so half of it going on about bud swell time before bloom, and then the second half of it going on at during petal fall, perhaps 3 weeks later. And what this typically does for us is provides nitrogen available to the plants during the early rapid growth flush from petal fall through green fruit. And then the second application later in the season tends to maintain adequate levels through the harvest period. So you may find that it makes no difference if you apply nitrogen in one application or two applications if you're on a heavier soil or a soil high in organic content. But I think you'll find benefits from the split application system, particularly on the sandier sites. And then the other point I wanted to make that you're probably aware of is that if you're growing blueberries in cold locations where winter injury is a concern, then applying nitrogen later than June should be avoided. And the reason is that it tends to reduce hardiness of the bushes going into the winter. So if you're growing hardy blueberries in a less stressful winter location, then you might be able to get by with applying nitrogen a little bit later in the season. But if you're growing blueberries where you're just stressed by the winter year after year, then this is where you want to be real careful about applying nitrogen or maintaining high levels of available nitrogen later in the season. A little bit about timing on brambles. Here, what I would suggest is if you're growing on heavier fertile soils, probably do just as well applying all your fertilizer at about bud break time in April or May. If you're growing on sandy ground that's low in organic matter, then you might go to this split application approach where you're applying half at about bud break and then half 3 to 4 weeks later. I think this will maintain levels of nitrogen available to the plants later into the growing season, and particularly with fall fruiting types, support fruit production way out into September and October. Timing for perennial strawberries. So here recommendations vary from the planting year versus fruiting years. But during the planting year, what we typically recommend is 20 to 40 pounds of nitrogen 2 to 3 weeks after planting. You want to make sure that this is delayed to where either irrigation or rain has settled the soil around the plants. And then a second application in August. So that would be during planting year. During during a fruiting year, things change somewhat. So here we're recommending applications of 30 to 50 pounds of nitrogen applied at renovation time after harvest, and then about the same amount of nitrogen applied in late August or early September. There are some some growers in Michigan I know that feel that they need just a little bit of nitrogen early in the spring of a fruiting year, and by a little bit I mean just 10 pounds or so if they're growing on very sandy ground. This is, I think, kind of a risky thing to do because you can generate too much vegetation by fertilizing in the spring. But if over time you find that that works for you on your soil, then that might be a good approach as well. And then lastly, nitrogen placement. So the issues here are really a balance between trying to put the fertilizer where it's available to the plant versus not concentrating the fertilizer so much that you create a salt issue and injure the plants. So with blueberries, what would be a good approach is to, with young plants, so in the first or second year, apply in either a 2 to 3 foot wide circle around each plant by hand, or in a 3 to 4 foot wide band down the row. Since these bushes are usually at a 10-foot row spacing, if you're broadcasting fertilizer over the entire surface, that's very inefficient. As the bushes mature, you can imagine that the root system of these old bushes probably intertwines in between the rows. So here, I don't think you get much advantage from banding any fertilizer within the row, and it's certainly easier to just broadcast fertilizer in older established plantings. And we talked a little bit about the salt index in the earlier webinar. So this is a measure of the potential for causing salt stress to plants. And I again wanted to reiterate that you often see these salt index values for different fertilizers, and if you consider these only, then you'd steer away from ammonium nitrate, for example, that has a very high salt index and a high potential for causing injury. And you might look more closely at calcium nitrate, for example, that has a lower salt index value. But these values are based on units of actual fertilizer. So if you're working in the field, of course, you're thinking about I'm going to apply, for example, 50 pounds of nitrogen. What's the best source of that? Well, if you're using ammonium nitrate that's higher in nitrogen, you would use less of that material. And so this last column is the salt index per unit of nitrogen. And you can see that numbers flip-flop, so ammonium nitrate might actually be more safe to use on younger plants than calcium nitrate. Another aspect of this, of course, is it's easier to hand apply more diluted fertilizers such as calcium nitrate than ammonium nitrate. Nitrogen placement in brambles, kind of the similar thinking here as with the blueberries. So during the first year, you'd be either applying it in a circle around each plant, or again in a band down each row. In established plantings, you're kind of to the situation where you might be a little bit more efficient by applying that in a band under the row, but in most cases, growers are trying to maintain a sod between the rows. So in order to fertilize the sod and fertilize the raspberries, it might be a better choice to broadcast under those circumstances. And then nitrogen placement in strawberries and perennial strawberries. Again, during the planting year, generally you're probably broadcasting fertilizer because of the close row spacing. I guess you could consider banding in a smaller planting, and certainly broadcasting when the plants are mature.
Eric, there's two questions on timing that we have. One was from Kathy, and I think, Kathy, you might have to jump in to clarify what you were looking at there. And then,
yeah, Eric, I was wondering when you said nitrogen in blueberry shouldn't be applied after June, if that was the middle of June, the end of June. I was hoping you could clarify that just a little. Thanks.
Just as a rule of thumb, I'd say no fertilizer after the 1st of July. So make sure everything goes on before July. And I'm looking for the box of other questions. Was there another question besides that, Kathy?
Yes, it's in the chat box.
Is it in chat?
Go ahead, Dan. Go ahead, Dan.
Yeah, Eric, it's in the chat box. Folks over in Oneida County wanted to know what's the right timing for nitrogen in ever-bearing strawberries.
Yeah, ever-bearing strawberries I haven't had a whole lot of experience with, but typically those are on plastic, so you're fertigating, and the timing there would be more of a spoon-feeding approach through the growing season. I think there's some real good information from North Carolina State University for plasticulture strawberry systems, and I think I'd suggest you take a look at that information. But in general, you're trying to grow a canopy throughout the season, and then to maintain fruiting for an extended period of time. If it's the first planting year on ever-bearing strawberries, then you're fruiting from August, September, and October, so that's a long period of time. You need to supply nutrition during that time. And then typically under our conditions, growers are trying to overwinter those beds for fruiting the following spring as well. So if you're, I would assume if you fertilize them well through the previous year, that you probably would not require too much in the spring prior to that um, June cropping. I hope that that answers that. And then there are wanted to mention organic sources of nitrogen, and we talked about this a little bit in the previous webinar, but there are a number of materials that to choose from here, a number of different plant product and animal product materials, so soy meal, cotton seed meal, blood meal, fish meal. Those are relatively high in nitrogen, and they release and make available a relatively high percentage of nitrogen content during the first year. If you're using manures, these, as we mentioned before, should be analyzed before you're using those, but typically they contain lower nitrogen concentrations and and release a lower percentage of nitrogen to the crop during the course of the first year. And then composts, of course, are aged and decomposed, usually plant materials. They contain lower nitrogen concentrations as a result, and they tend to be somewhat stable because they're aged, and they tend to release a lower percentage of their nitrogen during the course of the first season. So those are generalities, but I think a good rule of thumb is these products with higher nitrogen contents usually mineralize higher percentages of the nitrogen during the course of the first year. And then any compost or aged manures, for example, tend to be more stable and tend to mineralize and make available lower percentages of the nitrogen during the course of 1 year. There's a question, is it risky using fresh manure? And that's a great comment. So during production years, if you're using fresh manure, this should go on the year prior after harvest. And in with some crops, blueberries in particular, some marketers would advise no fresh manure ever being used in plantings. Thanks for that link, Dan. We've done a little bit of work with nitrogen release from organic sources and organic blueberries in Michigan, and I wanted to show you some of those data just because they illustrate kind of the release pattern for some of these organic fertilizers. So these are same material but two different rates. So this McGarry's soy-based 811 organic fertilizer was applied on May 10th, and then we simply watched the total inorganic nitrogen, so the ammonium and the nitrate levels and the soil profile after application. So you can see that there was a pretty immediate release of available nitrogen, and it tended to decline as the season progressed, but particularly at the higher rate, there was still elevated level of available nitrogen in the middle to end of September during this study. So there were no differences in nitrogen levels in the blueberry bushes, but it does illustrate that these, at least this material, tends to release nitrogen on a gradual basis that tends to mimic, I think, pretty closely the nitrogen demand by the blueberries. And here are some other similar data from a different blueberry field. So here we just use one rate of this particular nitrogen fertilizer, and it was applied at this point in time, and you can see that immediately there was an increase in available nitrogen from the fertilizer. Levels declined, but again, even towards the end of September, levels in the soil were elevated over plots receiving no fertilizer at all. So this presents a little bit of a concern about how you fertilize organic blueberries without elevating levels of available nitrogen late in the season, when we would like those plants to be slowing down and getting ready for winter. And we've seen in 2 of these trials increase in the level of bud damage during the winter because, I think, of this elevated levels of available nitrogen later in the season. The use of potassium. So here, most of these crops have a fairly high demand for potassium, and fields often require regular applications of potassium, perhaps not annually, but often on a regular basis. And the fertilizer choices really should be based on, of course, whether you're growing conventionally or organic. The cost per unit of K2O, whether you need other nutrients that might be in the fertilizer, and then potential hazard from chloride. So I'll talk a little bit about that. So the cost per unit is cheapest for potassium chloride. Potassium sulfate is somewhat higher cost. And potassium magnesium sulfate, or SOPO-MAG, is even higher cost per unit of potassium. The potential problems with potassium chloride or muriate is that it contains chloride, which in high enough concentrations can damage berry crops. Organic sources, there are organic sources of SOPO-MAG, of potassium sulfate as well. This is a different material than this, in that it's apparently less processed, so it's usable organically. And then, of course, wood ash contains a fair amount of potassium, but it's very alkaline. So if that's being used in blueberries in particular, it would have an effect of increasing soil pH. So rates of potassium for existing plantings, usually if a deficiency exists, 100 to 200 pounds of K2O per acre will correct those shortages. Growers over time that find that they need maintenance applications of potassium find that 50 to 100 pounds per acre is adequate to do that job. The timing isn't as critical as it is with nitrogen, because partly because potassium moves in the soil but much more slowly than nitrogen. So getting it on at the right time is not so critical. One point I'd make is that fall applications would be preferred if you're using the cheaper muriate of potash, so that would allow more time for chloride to leach out of the root zone before plants begin growing in the following spring. And it certainly would be the case if you were applying a relatively high rate of potassium, say 100 pounds of K2O or higher, and you wanted to use muriate, that would certainly be best applied in the fall. Keep in mind that excessive use of potassium can cause magnesium shortages, so I think Marvin covered this pretty well previously, in that there's a balance between the cations in soils, calcium, magnesium, and potassium. And if you continually apply potassium because you think that you need it every year, you can cause trouble with inadequate availability of magnesium to the plants. There's a question, how late in the fall can you apply potassium? It's, like I say, it is going to stay in the root zone over quite a few months. So you could apply it any time in the late fall. That potassium should be available to the plants the following spring. And the potassium fall application would allow this time for chloride to leach out of the zone. Phosphorus sources, nothing real striking here. There are a number of different materials to choose from. Conventionally, they all are very highly soluble and highly available to berry crops. If you have a need for phosphorus, then the ammoniated phosphates would be good choices. But if you're only interested in phosphate, then these are expensive sources of them. For organic producers, bone meal, fish meal are good sources. Rock phosphate isn't used too much, but I mentioned it because in very acidic soils, such as blueberry soils, the solubility is quite a bit higher. So it might be a reasonable source of phosphate for blueberries where the acidic soil pH increases the solubility of the material. Question about a good question, a common question about the use of potassium in the in the fall as an antifreeze or to increase the hardiness of bushes. And I haven't seen any data to support that. I heard it from a number of blueberry growers in particular, and there are some growers in Michigan that actually apply foliar applications of potassium in the fall, thinking that it helps to slow down the bushes and get them ready for winter. That may be true, but I can't say there's any scientific evidence that that's true. Something that probably is worth investigating. And along those lines, I think if you're working with growers and that a question comes up, or a grower indicates that I do this and it does good for me, you might suggest to them to leave some untreated check areas so that they can actually learn what the treatment did versus what they think it did. Magnesium and calcium. Here, sources vary from magnesium sulfate, Epsom salts, calcium sulfate or gypsum, potassium magnesium sulfate, and then calcitic or dolomitic lime. So typically, at least under our soil conditions in Michigan, if we're low in magnesium and or calcium, it nearly always indicates that the pH is too low. So the correction would be to apply either calcitic or dolomitic lime. Under our conditions, we tend to have more of an abundance of calcium relative to magnesium in the soils, so dolomitic lime usually is a better choice, but the soil tests will tell you that. If the pH is appropriate, then a source of calcium might be gypsum, Epsom salts, or sopomag would be good sources of magnesium. But like I say, I think that's fairly uncommon to see very low levels of magnesium or calcium in a soil with a proper pH. calcium and fruit quality is something that generates a whole lot of attention and interest, and for good reason, because elevated calcium concentrations in fruit tissue are often associated with improved quality, and quality is such an important variable in berry crop production. So we know, for example, that there's a reduced incidence of some physiological disorders of fruits if calcium levels can be increased. So bitter pit is a localized deficiency of calcium in apple fruit. So that's a fruit quality related aspect. We know that there's an increase in firmness usually that accompanies an increase in fruit calcium concentration. So this may relate to the inhibitory effect of calcium on some of the natural enzymes in fruit that are associated with the softening and degradation of cell walls and the natural senescence of fruit. So calcium has a direct effect there. And then there's also a reduction in rot that's caused by several fungal pathogens. And this may also go back to the inhibitory effect of high calcium concentrations on some of those enzymes that originate from the fungus that contribute to breakdown of the tissue. So all good reasons to think about calcium applications for improving berry quality. But what's known there? Well, we know that increasing calcium levels in berries can improve the quality of berries. And we know that from the fact that if you dip strawberries or blueberries in calcium solutions after harvest, that increases firmness in it and/or it reduces the rot incidence. And of course, dipping these berries in solutions doesn't have much commercial utility because it has quality issues in itself. But it does illustrate that if you had ways of increasing calcium concentrations in the berries, you'd probably see some benefit from it. So the most likely approach to increasing calcium levels in the berries is to spray the plants with calcium sprays prior to harvest. And there's been a number of studies in different parts of the world on these three groups of berries, blueberries and strawberries and brambles. And calcium sprays have sometimes increased firmness and prolonged the shelf life of berries and/or reduced botrytis rot. But I think the most consistent thing about these studies is the inconsistency. So these effects are seen sometimes and they're not seen other times. So this is another one where there's no clear answer for growers. I'd advise people, if they're interested in working with calcium sprays, again, go back to that rule of thumb. Try to make sure that you're leaving untreated areas so that you can tell whether your treatment actually did some good. Another approach, of course, to increasing levels of calcium in the berries would be to supply it through the roots. So this also hasn't been particularly effective. These are some data that we collected on a low calcium blueberry soil years ago in Michigan. So we selected the site because it was low in calcium. And then we applied either 1,000 pounds of lime or 500 pounds of gypsum each year for a number of years. And you can see that this had a very dramatic effect, particularly with the application of lime, of increasing the calcium concentrations in the soil, somewhat lesser degree with the use of gypsum. But what we found from a quality standpoint is that these modest rates of lime and gypsum raise the pH in calcium levels of the soil, but had inconsistent effects on the leaf calcium levels. And in 2 years, when we measured them, had no effect on fruit calcium levels. So they seemed to get calcium somewhat into the plant, but they did not get elevate calcium levels in the fruit themselves, which is where we want it. And the treatments, as a real result, had no effect on fruit yield or the shelf life or the firmness. So I thought this was a good test to talk about here because it was in a field that was low in calcium to begin with, and over time we were able to pretty dramatically increase calcium levels in the soil, but this had pretty minor effects, if any, on calcium levels in the plants, and particularly in the fruit where you'd like it. Boron is interesting micronutrient, and it can become deficient in berry crops. Generally, if there's a shortage, it causes poor shoot growth and dieback, or reduced fruit set, or sometimes fruit deformities. So these blueberry pictures were supplied by a colleague in Italy, where they were working with a Elliott site, and it was extremely low in leaf boron levels, down to 8 to 10 parts per million. They had these lesions developing on some of the fruit, these corky lesions, and those were corrected by boron applications. There was a question, is there a synergistic effect of calcium on nitrate uptake when applied as calcium nitrate? And it's a good question, and I don't know as I have a good answer to it. Calcium nitrate, of course, because you're applying only nitrate, can be relatively efficient if it's not leached out of the root zone quickly, or it may be very inefficient if you're irrigating heavily after applications, or you receive a 2 or 3 inch rain after your application. That will remove it all. And I don't know that of any specific effects of calcium on uptake of nitrate in particular. Getting back to boron, though, I wanted to mention that berries, like most crops, are very sensitive to excessive boron. So applications should be made only if the soil or leaf analysis indicate a need. So applying boron because somebody told you that it may correct deformed berries is a poor approach if you don't have some data on boron levels in the soil, and more importantly in the leaves. If there is a need, it's easy to get boron into these crops either through foliar applications applied early in the season to the foliage, or through sprays to the ground in the spring that could be applied with a weed spray, or even soil applications of granulated material in the spring. Iron deficiencies occur periodically, but these are nearly always related to a pH that's too high. So most common occurrence, of course, is in blueberries, where the pH, if the pH is above about 5.5 under our conditions, we start to see this chlorosis due to iron deficiency, or occasionally in bramble or strawberry fields, if pH is very high, you can get this similar symptoms. So the problem is really related to effect of pH, and dropping the pH is the only good solution to it. There are a number of foliar iron chelated products available, and those do provide some leaf greening if they're applied to affected bushes, but I question whether you really see an improvement in the vigor from those treatments. I think sometimes it's more of a cosmetic effect. Manganese. This is another micronutrient that where deficiencies can occur in berries in the Midwest, and from what I read, they're probably even less common in the Northeast, and partly because it again is usually pH related. So if the pH is too high, this limits the solubility of manganese and can cause deficiencies of manganese. And the reason that blueberries, of course, seldom run into manganese deficiency is that the pH is low, so it increases availability of that micronutrient. So if there's a need for manganese, check pH and reduce it. If it's too high, there are foliar sprays of manganese sulfate. Manganese chelates can be used. Some fungicides contain significant amounts of manganese, and those are pretty good sources also for labeled crops. Zinc, similar to manganese, we see deficiencies occasionally in berries in the Midwest, and I think that occurs also in the Northeast. And shortages, again, typically occur in soils that are sandy and too alkaline, too high in pH. Treatments here, again, check the pH, reduce it if it's too high. You can apply foliar sprays of zinc sulfate or zinc chelate products if the pH is appropriate. And there are some fungicides that contain zinc that can be reasonable sources for labeled crops. Yeah, and question, does manganese have some fungicidal properties itself similar to copper? I don't know that that's the case. Good question. I wish I could answer it. Copper and molybdenum. These soils in the Midwest and Northeast appear to supply adequate levels of these micronutrients to berries, and because deficiencies haven't really been documented. A colleague in Georgia indicates that rabbit-eye blueberries in those areas occasionally are deficient in copper. And he indicates symptoms include abnormally small leaves and short or shoot dieback during the winter. But I don't know that this has occurred in northern high bush and Midwest to Northeast. And again, there are fixed copper fungicides that are suitable sources. Copper salts can potentially injure tissues, so this is something that should be used with caution. But again, copper and molybdenum rarely, if ever, deficient under our conditions. And then lastly, I wanted to mention fertigation. And this is, of course, the injection of fertilizers through trickle irrigation systems. And the reason this is appealing is it's so convenient. And it's a way of increasing the efficiency of fertilizer use. So for berries in the ground, fertigation is most useful for delivering nitrogen and sometimes potassium or phosphorus. So the big advantages are greater control over nutrient placement and timing, and as a result, improved efficiency. So less fertilizer may be required, but there are some caveats to that. And then disadvantages, of course, are there's capital investments in injector and tanks and backflow valves and such. And then there's some maintenance and management costs involved in this as well. And many of these typical fertilizers are very soluble. So ammonium nitrate, ammonium sulfate, calcium nitrate, very high solubility. Potassium materials are somewhat lower in solubility. These solubility levels are pounds of product per gallon, so they're extremely high. 16 pounds per gallon is extremely high solubility. I wanted to mention that these levels are all measured at the 70-degree water, and solubility of all the materials is lower the colder the water gets. So if you're using well water, you may find that this is water will take maybe half as much of these materials as you can get into solution at 70 degrees. As one precaution is don't mix calcium with sulfates or phosphates. So as if you're mixing up batch solutions for fertigation, this is a general rule of thumb that these will cause precipitation and plugging problems as a result. And you're all probably familiar with a jar test, so you can always take proportions of these materials and mix them up in a jar to test for mixtures and concentrations that result in precipitation. The fertigation for blueberries and brambles, some general thoughts. First, I think if you're new to this, you can probably reduce your annual rate by about a third. So that's assuming there's improved efficiency. And what I would start with is to split that annual rate into multiple applications, 2 to 3 weeks, beginning 2 to 3 weeks after bud break and continuing through July for blueberries and into August for brambles. So that's kind of a general. You can fertigate weekly or every 2 weeks, or you can fertigate every time you irrigate. Generally, I think the efficiency that you gain, you would gain, that would be gained from a split application with 3 or 4 application dates. You probably wouldn't improve on that too much by even continual fertigation. So fertigation can be very efficient, assuming that first your irrigation system has high uniformity. So in the Midwest and the Northeast, we're usually irrigating to supplement precipitation. So if your irrigation system's not particularly uniform, it's not such a big deal. But if you're supplying all your nutrition through that irrigation and the uniformity is poor, then that becomes a bigger deal. Nutrients are applied when demand is high. So if you're fertigating and you're applying nutrients before bud break, before the bushes are able to utilize nutrients, then you probably won't be achieving the efficiency that you could be if you're applying them when the demand is highest. And then also assuming that plants are not over irrigated. So if you're irrigating and pulsing fertilizer through the system, and then you're irrigating heavily afterwards, it's very easy to push that nitrogen down through the profile and out of reach of the plants. This was just a ditch dug across a raspberry row under a high tunnel. So this is the trickle irrigation system. And just to illustrate, if you deliver your nitrogen where you should deliver it, and then you over irrigate after that, it's very easy to push it down below the rooting system of the crop. So here again, you'd lose the efficiency that you might have gained. And a question about any economic analyses of fertigation. That's a great question. I don't know of any per se. I can't really think of any. Something that would be useful if it were available. So we're just about out of time, and I wanted to thank Marvin and Kathy in particular for organizing this webinar series. I think it's been real good. So are there any closing questions or particularly comments? Anything you'd like to discuss further? The question, what guidelines for irrigation frequency, an inch per week in summer, for example? I think each, I would go to the strawberry, blueberry, and raspberry production guides out of Cornell. I think those publications do a great job of summarizing that information in detail. In blueberries and raspberries in Michigan, we always talk about an inch of water per week through the season as a rule of thumb. But I think you can generally do quite a bit better than that if you have a little bit more information available. Question: generally, when blueberries are mulched, they say to increase nitrogen rates a little, but doesn't that end get released eventually as the mulch breaks down, or does it disappear? That's another great question. In a perennial cropping system like that, over time you would eventually get to equilibrium where the nitrogen supplied the prior year will be partly released and through microbial decomposition of the older materials. So you're right that if you're applying a fresh mulch underneath blueberries, that effect on nitrogen availability really is during the first year. After that, you may find that you can go back to a rate that is consistent with a site that didn't have mulch applied to it. Now, in reality, a lot of growers would be applying mulch every second, third, or fourth year. So you'd have to make those adjustments over time. Bob is asking, have you seen times where applications of nitrogen are accidentally doubled or tripled? I probably have seen those, but I haven't known them at the time, Bob. With blueberries in particular, what's striking to me is how slow they are to react to fertility. So when we've done fertilizer trials where some of the treatments get a high rate of nitrogen, some of them get no nitrogen, it often takes 2 or 3 or even 4 years before you see a response in the bushes. So with these perennial plants like blueberries and probably to some extent raspberries, they tend to respond slowly to good things and bad things. Yeah, Charlie was asking cranberries also, and I assume you're asking about response to nitrogen. Cranberries are quite a bit more responsive to nitrogen than blueberries. So what you do in a particular year, you'll see the response to that year. Yeah, and a question, would a cover crop be helpful in tying up some of the excess nitrogen late in the season? And that's a great point, and it's absolutely true. So in Michigan, a lot of a standard cover cropping system is August or September seeded annual rye. And I think part of the benefit of that rye is it tends to soak up some of the excess of fertility in the soil and perhaps make that available the next spring. So good point. I think Kathy's saying thank you, so we're going to sign off here. Is that what that means, Kathy? Thanks so much for your attention.
And thank you, Eric, for joining us today. We have another webinar next week, and Kathy will be sending out information on that during the week. So have a good day, everyone.
Thanks again, Eric and Dan. Talk to you all next week.